Is Noah, and today we're going to be doing our network design proposal presentation. The things we're going to be talking about today are the project scope, feasibility study, network needs analysis, quality of service requirements, reliability and security requirements, network design, detailed design documentation, cost analysis, and finally how to test the network once everything has been completed. So I am not going to be spending a lot of my time talking about the paragraph, so if you just want to pause the video and read over it, then now's your chance. The feasibility study, this just kind of covers like what is the goal and how the network is going to work with everything and who's going to be using it, that sort of thing. The main points I want to talk about is that we're trying to set up a wireless network for the community college that will house students, staff, faculty, guests, all of those people, and basically allow them to get their jobs done and tasks done without being restricted to a wire. For the updates and integration, we want to at least have 802.11n running at the least, and make sure that it works well with the already established wired connection. For the scalability, once everything is successful, it mainly just comes down to replacing hardware and then reconfiguring that hardware once everything is set up. For the design assumptions, we're going to need at least 2 routers, 2 controllers, and about 50 or so access points. These we will be talking about in a later section. For the equipment needs and proposed budget, like I just said, we're going to need 2 routers, 2 controllers, 2 access points, and then the estimated cost for all of these is going to be around $30,000. For the network needs analysis, this is just kind of like what the network's going to be doing and what's going to be running across it, and the sort of things that going to be running across it hopefully are just going to be things like homework, messages, emails, grading, going back and forth between the database, emails, accessing online textbooks, downloading documents and rubrics, printer jobs if certain people need to use a printer on campus, and then accessing the internet for small things. I don't think too many people are going to be like playing video games on a college campus or anything like that. For data sources, it's mainly going to be the student body and staff. I don't imagine a whole lot of guests being there, but we'll have something set up for them that we'll talk about later. So I'm guessing probably around 1,000 students and connected on average. And then obviously when you want to figure out your speed requirements, you're going to want to give some leeway to that so that you can really see just how much room you're actually going to be using if it gets a little bit too crazy. Of the speed requirements, I was using a formula by Tenanza, I believe is how you pronounce it, and their formula is basically low, medium, and high, and what that is a population number, and then they give you an amount of kilobytes per second data that they would be using. And the total population, we're going to do roughly 1,500. Just say there's a crazy day on campus where there's a bunch of people there, and like I was saying before, just like the leeway. So adding all of those numbers into the formula, you want to use about 50% of the population for low, 40% for medium, and 10% for high. You come out to roughly 1,215 megabytes per second. Variation estimates, our hardware that we're going to be using is going to peak at around 3.46 gigabytes per second, and the average usage is about 1.215 gigabytes per second, and max usage is 3 gigabytes per second, which means combining both routers you get about 6.92, which means at average usage you're only using about 17, and at max usage you're only using about 43. And like I said before, that 1,500 that we did the math with was leeway, so I'm pretty sure we're going to be using a lot less than those percentages on a normal basis. The next thing we're going to be talking about requirements. And what quality of service does is it basically smooths out your bandwidth distribution based on what you need it for. So the main things that we're going to be configuring for quality of service so that you have near flawless connection through is voice over IP and application databases. And for most things like grading and emails, we want to have like a guaranteed data flow for that so that you don't lose any of that, as that could impact student grades if stuff like that doesn't get through. And one of the things that will definitely help with this regard is a content delivery network. And having one of those set up in conjunction with your QoS is a great combination. And then monitoring traffic will also help you be able to give the right QoS settings to like lower level things that you wouldn't find as important as the voice over IP and application. The next thing we're going to talk about is the reliability and security requirements. Users in a college campus are going to want 100% uptime. There's always going to be people up really, really late. There's always going to be people up really, really early. The only real time you're going to want downtime is probably over the summer when there are no classes, but even then staff is still going to want it, so it's best to just have 100% uptime. For most of the security that we're going to use, we're just going to use like website blocking, basic firewalls, encryptions, password locking, important documents, like Microsoft Word has the option to create a lock on the document itself, so that even if someone does get access to the document, they have to have that password in order to read anything on it. Creating backups is always a good option. And then for Wi-Fi logging in, username and password, just so that it's just not one thing that a hacker or someone trying to get in would have to guess. They would have to get the username and the password. And then MAC address filtering to take out any MAC addresses that aren't supposed to be there. And then Rogue Scanner and NetStumbler are just two examples of some third-party programs that do a very good job. Rogue Scanner gets rid of any rogue access points, or at least it'll scan for them and let you know when one of them is there. And NetStumbler is a great one that goes hand in hand with the website blocking. It kind of just runs around on the internet, and anything that it deems to be unsafe, it will let you know so that you can block it. So the next thing that I have right here is just an upgraded network design diagram. So on the top here we have basically just a switch that our routers are going to connect to, and then in between the switch and what is supposed to be the internet, we have just a basic firewall on the switch that will block any bad incoming internet traffic. And then we also have two firewalls in between our routers just to keep any incoming from like the client desktops and stuff, keep anything like that from getting to our databases and stuff. And then below the routers, we just have our wireless controllers, and those will manage the access points. And the two circles around the access points are just there to say that the controllers can only manage 25 at a time, and we need 50, so we'll just have two groups, one for each router. And then obviously the computers down at the bottom are just devices connecting to the access points. This is the detailed design documentation. These are just the three things that we're going to be needing to set up our wireless network. This just shows the price, its availability, a few of its things that it will do, such as it being 5 to 25 access points with 30 maximum groups, how many gigabytes of throughput. The access point itself allows for dual 5 gigahertz radio support instead of one being 2.4 and one being 5. You can actually set it up for both of them being 5. Cost analysis, and this is one of the main things for the business aspect of it, you want to know how much things cost, and this just breaks it down in a nice little neat format. So the estimation was right about $30,000, and this actually runs out to about $29,546. The testing plan that we have for our network is before and after setup, you're going to want to run a heat map. This is a great tool to use if you have a lot of access points. You want to make sure that there are no dead spots, and that's perfect. And that's exactly what a heat map is going to do for you. It's going to let you know where those dead spots are so that you can plan the access point locations accordingly. Check RF interference, things like PHY, RSSI, SNR, channel usage, RF utilization, and initialization. Testing with the bring your own device and outside devices is good as well, just for like guests and stuff like that. Running a speed test just to make sure that your service is running at full capacity. Penetration testing with things like Wireshark and Nmap to make sure that your network is secure for people that are just floating around on the internet trying to pick up things that they shouldn't be. And then ping testing just to make sure that at any point on the campus you are still able to reach a certain wireless device. And that is the conclusion of my presentation. Thank you very much for listening.